See this?
Just 1 minute. Now we can all see it.
Wonderful. All right, thank you very much. Hey, everyone. My name is Zack Singer with Verdant Evolution, and I'll be walking us through how we bring your workflows to life with intuitive interfaces backed by some solid software. First, a bit about us. I founded Verdant Evolution with my co-founder, Kevin Welsh, in 2023 to support research groups with bringing their novel technology to production deployment. And that doesn't just mean academic research, but also industry research groups wanting to harden their proofs of concept into a product or a service. Our primary areas of focus right now lean into building intuitive interfaces for robots and strengthening cutting edge software solutions. We're currently working very closely with Cornell University and University of Dayton to support their material science divisions. So when building a new technology, there are a lot of complicating factors. It requires subject matters in the field, subject matter experts in the field, and often their expertise doesn't quite overlap with the software development that a complete solution would rely on. When a proof of concept is built, there are some large technical and communication gaps to overcome to move to the production ready stage. And that's where our core support comes in. When we're asked to help a team move up the technical readiness ladder, our first step is to understand what workflows the users expect to be able to use. And that understanding helps us identify the technical gaps that exist in the core technology. And from there, we can build a robust execution plan from design time through the deployment of the solution. And lastly, no project could really be called complete without confident ownership, and that crucially includes well-crafted user and engineer documentation. So to give you a concrete example of what we do, let me first describe the Cornell synchrotron, which is a particle accelerator on their campus where many laboratories can conduct different types of X-ray based research. Some of you may be familiar with them. We work closely with one of their groups conducting material science experiments, and they partner with the Air Force Research Laboratory. Their charge is to build a scientific workflow to analyze a given material sample by using a robot, you can see here, to position it in a precise orientation along the X-ray beam. On the right here is their lab with their large KUKA robot to hold their samples, surrounded by a lot of really specialized equipment. And one of their major issues that they run into is that this machinery is very expensive. So the ability of the robot to actually navigate this cluttered space safely is really important. So knowing the issues they faced, we actually developed this graphical user interface for beam scientists to plan out their experimental procedure visually. First, the user creates their experimental plan in this GUI, and then that plan is translated into robotic motion that uses knowledge of the lab setup to avoid machinery in its motion. With a CAD model of the sample and a specified grid of points where the scientist is interested in taking data from the X-ray beam, that process of creating and running the experiment in an automated way is made a lot more possible. It's then kicked off and run with no human interaction. We've also been pretty heavily involved in processing some large quantities of image data from various types of experiments. I'm not going to go too in depth with these particular projects, but we've been pretty good at handling and processing enormous streams of data, upwards of 19 gigabits per second for many hours. This is the first example here is actually also from the Cornell synchrotron, where scientists have about 20 minutes of active time where they're collecting data that they care about, and then they're just sort of in a holding pattern for 4 hours while they wait for their data to process. It's a huge time sink for them, even with their vast compute resources. But we were able to take their code, replace some of their algorithms with more efficient techniques, and now they're effectively able to run about 3 times as many experiments per day as they were before we worked with them. The second project is actually something I'm personally pretty proud of. We were able to take some software that required a user to manually analyze each image from an experiment and automate the entire thing without a human in the loop. Now they're running this analysis for their research in real time, and this opened up the door for them to explore novel types of research. So definitely reach out, shoot us an email, or find us on our website. We're actually new members of ARM. We just joined last year. We're really enjoying learning about all the work being done here. We're especially interested in collaborating on project calls, but if anything that we've talked about here resonates with you, give us a shout. Thank you very much.
Thank you, Zach. And friendly